Welcome to our Just the Basics. This is the beginning of a series of these you're going to do. This is by far algebraically the most simple of those, and you're going to find out, it's just going to reinforce what I talk about all the time, that calculus is easy. The algebra gets tough for us. So congratulations. As far as becoming a successful calculus student, you've got about 80% of the hard work done, because your algebra skills by this point are very, very strong. So now we're going to work on that and the precision there within. So here's how this is going to work. Of all the things I'm asking up here, and I'll let you read through those, I've got a place for those solutions down below. And this is not going to be like the assignments that you've turned in before that, hey, I want to see work shown, I want to see that it's complete. These are going to have to be 100% accurate, or there's not going to be a score recorded for them. So we really want to take our time. This is definitely not one that we want to race through. These are going to be relatively short assignments. I mean, it's many, many parts, but it's just one problem. So if ever there was a time to double check work, you want to do it here. So the first thing says show a complete graph, and we're going to try to battle through these. Some of the functions will be more difficult. You can always check this with your calculator, but we're going to want to have a graph, and I'm going to use the sprinter, intermediate runner, distance runner technique, which there'll be some things that are not maybe entirely accurate on it that I'll explain, but I'll definitely have a good global representation or a good shaping of the graph. I know we start down. After that, we're going up pretty steep, trying to come back twice as fast as a regular upside down parabola, and eventually looking like a negative cubic. So once I start going up here pretty steeply, I know that we're cupping down, so we got this kind of cupping down look, and I know it's being brought down by this as well. It's very possible this thing doesn't make it up to the x-axis, but it might. I don't know that, but I do know it's going to end up looking like that. So we're rising but cupping down. Now to the left of, once I leave here with a slope of 3, the graph is trying to get steeper down for a little bit, but eventually this term is going to win out, and we're going to talk about all those things. So here's what I see. We're going down, cupping down, going down, cupping up, going up, cupping up. Somewhere in here we must shift to going up, cupping down. And after here, we're going down, cupping down. And I'm going to repeat that after I go through this sign chart with you, and it's going to all be confirmed for us. It's kind of neat. It's just puzzle pieces. So the first things we want to do are find our first and second derivatives. The first derivative exists. The first derivative is 0 here and here, because that's the only places on this curve where the slope is 0. So I want to find the first derivative, set it equal to 0. So let's go ahead and go y prime is negative 6x squared minus 4x plus 3. And as I said, if ever there was a time to double check steps, this is it. If you miss this, everything is going to be wrong from this point on. So I'll record that. Negative 6x squared minus 4x plus 3. I'm then going to set that equal to 0. See, the slope is negative, then it's 0. Then it's positive, then it's 0. Then it's negative. I want to know when the slope is 0. That's my max and min. So I get, I think first thing I would do is multiply both sides of this equation by positive 1. It's probably not really right to put it equals 0 there. So I'm going to multiply both sides of the equation by negative 1, so I get 6x squared plus 4x minus 3 equals 0. Now understand, that's the derivative, but after I set it equal to 0, it's just an equation. All right, so let's go ahead and try to factor. Factors of negative 18 add up to 4. We don't have those, so If only there was some kind of formula. X is the opposite of 4 plus or minus square root b squared 16 minus 4 times 6, 24, times negative 3, negative 72, so that actually becomes plus 72, all on 12. That is negative 4 plus or minus square root of 88 on 12, or negative 4. This is 4 times 22, so square root of 4. 2 square root of 22 on 12. Reduced by 2 on 2, we get negative 2 plus or minus square root of 22 on 6. And those would represent these points right here. So let's go ahead and take care of that. That's our max and min. Here's a mistake that's often made. Everyone will recognize this as the max. That's not the mistake. But oftentimes I'll have people say, well, negative 2 plus square root of 22 is big. Negative 2 minus square root of negative 2 is little. So the negative 2 plus square root of 2 on plus square root of 22 on 6, that must be the maximum. It is the maximum, but not because the x value is big. It's because that's where the y value is big. Okay? So if this graph looked like, if this graph looked like this, our minimum would actually be our big x value, not our little x value. So we've got a maximum at negative 2 plus square root of 22 on 6. We've got a minimum at negative 2 minus square root of 22 on 6. The minimum is to the left. Okay, then B, now we're going to find the second derivative. Again, the derivative of this, not the derivative after I multiplied by negative 1. The derivative of this one is negative 12x minus 4. When I set that equal to 0, I get x equals add 4 divide negative 12 is negative 1/3. So our second derivative, negative 12x minus 4, and this negative 1/3 is where the steepness quits increasing, starts decreasing, or vice versa. We're cupping up, cupping up, cupping up, and somewhere in here, excuse me, we shift to cupping down. And that is at negative 1/3, not down negative 1/3, to the left negative 1/3. So we have an inflection point at x equals negative 1/3. Okay. And now I'm going to do a sign chart, which I'm going to require from you. And we're interested in these values. Now notice, I could actually rewrite this as negative 1/3 plus or minus square root of 22 on 6. And the point I'm trying to make is if I go to negative 1/3 right here, to the right and left of there, the same distance, is our max and min. In other words, negative 1/3 is between these. Negative 1/3 is between these values. So I'm going to put negative 1/3 here. And the second derivative is 0 at negative 1/3. Let's put a value bigger than negative 1/3 in, like 0. If I put in 0, something to the right of negative 1/3, I get negative 4. If I put something to the left of there, like negative 5, I get negative 64. Hang on. Excuse me. If I put something like negative 5 in there, I get positive 60 minus 4, 56. I get positives. Now take a look up at our graph and watch how this fits. This is second derivative positive. That means concave up followed by concave down. Cupping up followed by cupping down. Kind of neat how that fits. Then the second derivative is 0 at negative 1/3 plus square root of 22 on 6, or negative 2 plus square root of 22. I think I said 26, but on 6. It's 0 here and over here. Negative 2 minus square root of 22 on 6. And now let's put a value between these. And I could use negative 1/3, and it wouldn't be bad at all to put into the first derivative formula. But I could also use 0, because take a look. Square root of 22 is definitely more than 2. So negative 2 plus more than 2 is more than 0. This is less than 0. So I'm going to put in 0. I put in 0, I get 0, 0, 3. Positives in here. Something to the right of this. Let's see. Square root of 22 is a little less than 5. Negative 2 plus a little less than 5 is a little less than 3. So anything beyond 3. Let's just say I put in 10. If I put in 10, I get negative 600. More negative. Oh, it's definitely negative out there. And if I put in, let's say, negative 10, I get negative 600 plus 40. Oh, this is negative out here. Now watch how this fits together. This means the graph is going down, cupping up. Going down, cupping up to here. Now let's look at our next interval. Going up, cupping up. So it gets to here, then it's going up, cupping up to right there. Next interval. Going up, cupping down. Going up, cupping down. And last interval, going down, cupping down, going down, cupping down. So here's what we've got at this stage then. Where is the graph increasing? It's increasing based on the first derivative. So it's increasing from negative 2 minus square root of 22 on 6 until it gets to negative 2 plus square root of 22 on 6. Where is it decreasing? From negative infinity to negative 2 minus square root of 22 on 6 in union with negative 2 plus square root of 22 on 6 until we get to infinity. Or we don't get to infinity as we approach infinity. When is it concave up? That is second derivative. It's concave up from negative infinity until we get to negative 1/3, and it's concave down from negative 1/3 forevermore. But I will tell you, before I would submit this, I would most definitely look at that again. Otherwise, you're going to be starting all over on it. So hope that makes sense to you. Feel free to contact me with any questions you have regarding that. This is the first of a series, and reminder, you have to have work shown for those derivatives, and eventually you're going to have, on some more complicated ones, you'll have some more algebraic things to do up here. You'll see that when it comes, and you'll have to have each of these items, including your sign chart, completely correct. So this is most definitely a short but a precision-based assignment for you, and that's what first semester calculus is about. Let me know what I can help with.